So the problem is best time to buy and sell stock. So this problem can be solved using kadanes algorithm. Today I am going to explain this problem by using the kadanes algorithm. What? So please read the problem before coming to this video. So using kadanes algorithm, what we can find? We can find the maximum sum subarray in the given array, right? So here how can we use that maximum sum subarray concept? Here we just require the buy and sell variables like buy and sell prices, right? So we need to know only the buy price and the sell price. So in order to get the buying price, in order to get the profit, we need to sell at some point which can which will be greater than the buying price. uh, Suppose if I suppose if we know that a naught is less than a4, we definitely know that this can give the profit, right? So in order to get that profit, what will we do? We will be doing a4 minus a naught. So here the subarray sum, suppose if we sum if we sum all this, we won't be getting this a naught minus a4 minus a naught, right? In order to get that, what we can do is we will be maintaining one separate array like some b array which we compute from this array, like b naught will be 0, b1 will be a1 minus a naught, and b2 will be a2 minus a1, and b3 will be a3 minus a2. B3 will be a3 minus a2, and b4 will be a4 minus a3, and b5 will be a5 minus a4. So in that way we will be computing one separate array like a b array. So we'll be using this in order to compute, in order to get these transactions, in order to get profit. So suppose if we want a if we want a profit from this by buying on 0th day and selling on 4th day, if we want to get that profit, we'll just need this a4 minus a naught. So if we sum all this, what is the extra part we are getting? We are getting the extra part as this. So in order to remove that, so we will be maintaining this. So in order to remove this, we will be using this pre-computed b array. Suppose if we want, so we want a profit from by buying on 0th day and selling on 4th day, right? In order to do that, I will be using the b array from b 0th day to 4th day. I will be summing all this. After summing all this, what I can get? I will get a4 minus a naught. How I get? I will show you here. Here b naught. This will be b naught. It is directly 0, right? Here a naught minus a naught, because there is no previous value, so that's why I will make this as directly 0. Next what I will do, this is plus, and this is b1, and this is b2, and this is b3, and this is b4. So here what I have written, the same I have written here. So here a naught minus a naught will be 0. So a1 minus a1 is cancelled here. A1 minus a1 is cancelled, and a2 and a2 is cancelled, and a3 and this a3 is cancelled, Why? Because this is in we want to remove this all, right? So here negative sign is making us to remove this a1, a2 and a3. So this is the way we can remove this sum, and we will be getting only the profit from 0 by buying on 0th day and selling it on 4th day. In that way, while computing the sums, we will be maintaining the maximum profits. If the sum is becoming the negative, for suppose there is there will be some cases, right? Like a4 a naught is greater than a4, right? So there will be some cases when this case occurs, the sum will become zero, right? In the some maximum subarray sum, what will be do? We will be computing the sum from 0th index to some ith index. If the ith index makes the current sum as negative, we'll just make it as we'll make sum as zero, right? For the next next iteration we will make the sum as zero. We don't require the negative values. We will be starting from the positives, or if there is some other negative value, we will be starting from that negative value only. We don't require the sum to be going least, like we require the maximum sum, so we will be computing only the maximum sum. We need only the sum which is making the sum increasing manner. We don't require the decreasing sum. So in that way, when the sum is going negative, we will make the sum as zero. Why? Because we don't require the negative profit. But this algorithm is purely it can work with the negative values also. Like it can work with negative values. When the interviewer asked this, you can say this algorithm. It can also work with the negative prices also. Wait, I will show you also negative prices. First, I will show you the positive prices, and I will explain you with the negative prices. Why? Because in this problem we only have the positive prices. I'll show at the end for the negative prices. So we got the transaction from like we got the profit for this a4 minus a naught. In that way, in the middle we will be getting the maximum profit. So I'll be showing the code for that. So here what I have done is I have declared a variable sum as we declared in the maximum subarray, and maximum profit which will be which we will be returning at the end. This is the maximum profit we have generated. At the end we will be returning that. So in the middle we will be using the B array, right? So instead of maintaining a B array like this, instead of maintaining a BRA BRA pre-computation, what I have done is I have directly used this formula here. So this will remove the space complexity, uh, and when the sum is when the sum is negative, we don't require that sum, right? So I have made that sum as zero. We don't require the negative profit. So when the sum goes negative, I'll make the sum as zero, and in the middle, what I will do is I will maintain the maximum profit. So here in this examples, I will show you how this uh, code can work with this sample input. So initially the sum is equal to 0 and the maximum profit will be 0. I will be starting from 1 because 0 index, if we buy at 0, 0th day and sell at 0th day, we don't get any profit, right? So I'll be starting from 1. So the sum will be a1 minus a naught, sum plus a1 minus a naught, 0 plus 1 minus 7. So if we select 1 at day and buy at 0 at day, we get the profit as minus 6. So we don't need any negative profit, right? So I'll make sum as 0, and maximum profit will be no, will not be changed anything, it will be 0 for the I is equal to 1 iteration. So next I will go to 2, I will go to 2. So sum is equal to sum plus a2, a2 is 5 minus a1, a of 1, a of 1 is 1 5 if we select day 2 and buy at day 1, what is the profit we got it as 4. So maximum profit we got as 4. So the maximum profit is updated to 4. And if we when the I is equal to 3, sum will be if we if we select 3 and remove this a2, like I have said before, right? So this middle 5 is removed here, a3 minus a2, this 2 is removed, a2 is removed here, this minus a2 is removing this plus a2 before I have computed sum, right? So this a2 is removed. So 4 4 plus, so previously the sum is 4 plus this 3 minus 5. This 5 is removed, and 1 3 minus 1, which is uh, 2. 2 will be the profit that we are generating by after removing this sum 5. Here our sum became 0, right? Because this made the negative transaction. So we will be seeing this positive profits, positive sum only. So 3 minus 1, which is 2, is the profit that we have generated by buying at day 1 and selling at day 3. Next we will be continuing the loop, and at I is equal to 4th day, uh, what will we do? We will be removing the 3rd day. This 5 3 is removed previously, so now 3 5 3 is removed, and 6 minus 1, which is 4, 6 minus 1 is 5. So we will be getting the 5 profit for this by removing 5 and 3 while computing the sum. Here 3 is removed. How it is removed? Here it is positive 3, right? When we do on the 4th the day, we removed that 3. Previously 5 is removed at a index at day 3. So in that way we will be getting 6 minus 1 6 minus 1 profit, it will be 5 on so maximum profit is updated. Previously it was 4, now it is 5. Next when the I is equal to 5, sum will be sum plus array of 5 minus 4. So this 4 is, this 4 will be removed. uh, Here what we have done is we have removed all this part and computing the profit. 4 minus 1, which is 3. So here we got 3. After expanding this formula, we have kept these values, we have got 3. So I will update the maximum profit, and the maximum profit is 5, since 3 is not a maximum profit. So this 1 and 6, so buying on day 1 and selling on day 4 gives the maximum profit. So I will be returning this maximum profit, and this is the code for this, and this time complexity is of 1. O of n, and the space complexity is O of 1. O of n because we are only using the single loop, and there is no space extra we have used here. So, so this is the algorithm and code for this. Thank you.